All right, so let's talk about www, the World Wide Web, TCP, DNS, and HTTP. www stands for World Wide Web, TCP stands for Transmission Control Protocol, DNS stands for Domain Name System, and HTTP stands for Hypertext Transfer. www, which is World Wide Web, is a network of computers that are using the internet and are able to exchange web contents, that is text, graphics, and even multimedia, using standard protocols. Now, you can see it says network of computers that are using the internet. So it means that the internet is not the same thing with the web, but the web is on the internet. So meaning that the web is a service on the internet. There are other services that run on the internet, making internet an infrastructure. Okay, just like the way we have the road network that we see in our communities. Okay, so many things use that road. The trucks, people that are moving by foot, and what have you. So many services have been conducted on that physical road. So also we have the internet, which is a global interconnection of networks. And we have so many services that are running on the internet, and one of them is the web. So, and the web has to do with exchange of web content, okay? Both text, graphics, even multimedia, some web pages and what have you. So we'll take a look at those things later. Then the second point that is there is that the web uses client-server computing, okay? So this means that web servers are connected to the internet with specific content for communication devices to access, while web clients, which are desktop computers, mobile devices, etc., they access these servers via the browsers that are installed on them. So a server is different from a web server, okay? We're talking about web, so we're focusing on web server. We'll see the difference in the coming video. So now, the web server is connected to the internet. So, for example, Google Web Server, okay, which is located in Google Data Center, wherever it is that they have more than one data center. So, data center is a place where you see their servers and their databases and everything is stored, where an office where they manage their infrastructure as a service, their building where they host their servers and everything. Okay, so not only Google, we have other companies that build data centers. So these data centers are powered 24/7. So 24 hours, 7 days a week, they are powered. So to ensure that their servers are always up and running. Servers are more like computers, okay? Okay, but these computers have information that you can access. Okay, now some servers are private, but when we're talking about the web is using open protocol. So, even though you can secure it, but it's available for everyone to see, but you can decide to protect it. All right, so we are saying here that the web uses client-server computing. That means there's a server and there's a client. So the server is connected to the internet. Okay, so it's available for people to access. Then your client is your device, and the browser is specifically, okay, what allows you to give you that channel of communication with the server. So your browser, which is your client, on your phone or on your laptop or whatever you are using to browse that server or make a request to and from that server. So your client is the one on your phone. So that is the architecture. That is how it's designed to work. That there will be a communication between the client and the server. Okay, so the server is connected to the internet. It's not, they call it, some people say the cloud. It's just as if there's somewhere in the atmosphere or in the sky where this thing happens. Okay, it's not like that. The internet is an infrastructure, interconnection of computer network. So server is in the data center connected to the internet. And when you connect your own computer or your own device to the internet, you are already part of that internet. So making it possible for someone to even access you. Okay? All right. You can start up your own server with your device, all right, that people can come and fetch or what have you. So just need to understand the architecture. So next, let's look at TCP/IP. TCP is Transmission Control Protocol. Now, TCP, we saw that we were talking about OSI model in the previous video. So we saw it in layer 4. Layer 4, we have TCP, we have UDP. So this TCP is connection oriented. It means that this is the one that ensures that data is delivered. So when you make a request or when you send message to someone, you are going to get a feedback that message has been delivered. Or it also ensures that the information that is sent is complete. For example, if you are downloading a video, okay, it ensures a reliable delivery. Or you are downloading a document, not necessarily a video, downloading a document, okay, or you are downloading anything, that thing must be complete in your own client. You are fetching that information from the server, so it has to be complete. So it uses the TCP protocol to ensure that what the information has been received completely. Then UDP is connectionless, that is user datagram protocol. It's connectionless. Okay, what that connectionless means is that when you send something, it doesn't request for a response, unlike TCP. Okay, so that is different. More like if you are making a broadcast. If someone is televising and they are making a broadcast on the television, it's only people who turn on their television that will be able to see the person that is giving the broadcast. And even at doing that, you cannot just directly interact, like giving response immediately on whatever that is being happening, that is being televised at that point in time. So that is an example of UDP. And if you are streaming a real-time video, it is time bound, so it is real time. So you want to be watching it in live. So if anything happens to your network, those ones that you were viewing when the network was, the data that others were viewing when your own network was bad, when your network comes back on, you will resume the match or whatever thing that you're streaming live, you resume it at the point at that particular time, not minding where you were at before your network got bad. So that is an example use case for UDP. Okay. Sometimes you want to send messages. If you on your phone, for example, if you open your SMS app and you send someone a message, okay, if you have not configured that your phone to send you to allow for delivery message to be sent, the message will just write sent, but maybe the person will tell you that they have not received the message. Do you understand? So that is another example of UDP. But TCP, for example, if you enable that delivery message, you are automatically enabling what? TCP, which means that once the message gets to the person's device, that device is going to give you a response that, see, I got it, I got the message, and then your phone will tick double good to show that what that message was delivered. This is a critical example of TCP and UDP. So I hope you understand that already. Then we are looking at IP. IP means Internet Protocol. This is the protocol that works in layer 3 of the TCP/IP stack. So layer 3 is the network layer. So this is the layer where we say we have source IP address and destination IP address. IP address is a unique identifier for every device on a computer network. There needs to be a way that a device is being identified on the network. So we have IP address. So IP address has two versions, IP version 4, IP version 6. Okay, both versions are currently in use, but before IPv6 came, we have IPv4. IPv4 is 32 bits, okay, wide, that is the size. So the capacity is that it can receive up to 2 raised to power 32 number of, can generate 2 raised to power 32 number of IP addresses. Okay, while IPv6 can generate up to 2 raised to power 128 number of IP addresses, which makes it much, so you can be able to reach out to multiple devices with IPv6 than IPv4. So that is where the world is going to now. Many devices will be able to have IP addresses. As little as a device may be, they will have IP addresses, because we're talking about Internet of Things now, where you have the internet and you have gadgets that are connected to the internet remotely, like microwave and other things, being monitored remotely, drones and what have you. So those devices, they need to have the IP addresses for the network to be able to identify them. So IPv4 has been used up and we are using IPv6, even though there are ways to manage IPv4 currently. So, but IPv6 is the way that people are writing IP addresses now. Now, the format of IPv4, we have 4 clusters of 8 bits. So we have a cluster, and another cluster. So we have 4 clusters. So this WXYZ represent 8 bits data each. So we have 4 clusters, which is 32 bits. 32 bits. 8, 16, 8, 16. So 16, 16, 32. And we have IPv6. Look at the format. A colon, B colon, C colon, D. So this one is using colon, not dot. Okay, so where you're having clusters of 16 bits. So each of these A, B, C, D, E, F, each of them, they are all 16 bits. So it's wider. Okay. All right. In a later video, we are going to do some practical so that you'll be seeing IPv4 and IPv6, how they look like and where they are used. Okay. So more about TCP. So we're having this diagram here where we have web server and we have another web server. The two, they are communicating amongst themselves. Web server by the left sends 3,000 bytes, 1,000 bytes each. Web server on the right. Now, the first 1,000 bytes went successfully, but the second 1,000 bytes did not go successfully. Let's say maybe network failure or something happened along the way. Then the third 1,000 bytes went through successfully. Now, because of TCP, the server that received it, the receiver, will send a response to the sender saying that it received the first 1,000 bytes and the third 1,000 bytes, but that it does not receive the second 1,000 bytes. So that information will get back to the sender, and the sender will resend the second 1,000 bytes to what? To the receiver. And then the receiver, after receiving the second 1,000 bytes, will now say, you can now continue to send the fourth 1,000 bytes so that their communication will continue. That is, if that is not all the data that is needed. So you can see that TCP helps to monitor that everything is properly delivered to the receiver. So it is very, very important. So we have popular applications and their port numbers. So we have different applications and we have FTP, file transfer protocol. This is a protocol that enables uploading and downloading of files. Yeah. This one is outside the web. Web is port number 80. Okay. The web, that is HTTP, port number 80. This is web. We have DHCP. All these things run on the network, not only web. So you see different ports. So port numbers are a way that we, in networking, that is used to recognize different services that run on that network. And then you can be able to address them one by one differently using the port number. Okay, so a request can come to your server, but that request can be going to port number 20, which is for FTP, and not port number 80, which is the web. So how your browser finds out that the information needs to be opened in your browser or something is when it has to deal with port number 80. So there are other requests that are happening in your system, your computer network, that may not be web. So in that case, it will not even affect the browser. It will just go for other activities on the web. So we are saying that TCP/IP uses port number to know which application to address its packet. A packet is a bundle of information of data that is an encapsulated data that you are sending to a receiver. So that message that you are sending to the receiver is a packet. We call it a packet. So TCP/IP uses port number to know which application to address its packets. So that which is proper to the service requested. All right. So port numbers are also used to give or deny access to any service on the network. For example, if I want to block anyone from browsing, I'll go to my Windows firewall and block port number 80. Okay, so even maybe on a Cisco switch or something, I can go there and still do the same. So that is the thing that is there. So it's good to know the port numbers of certain services. SSH is secure shell. Telnet is there, port number 23. See, these ones are using TCP. Web uses TCP, while something like DHCP uses UDP. DHCP is Dynamic Host Configuration Protocol. Okay, so we have the one on the server, we have the one on the client. Now, how it works is that when you connect to a network for the first time, the client will begin to ask for IP address from the server. The server will issue the client an IP address. Okay, so that is a DHCP request. The request is coming from the client. The server sends a response. It is UDP because a client can ask and not receive anything. Okay, so that kind of thing. So you should take note. Then we have other things that are here. You can see DNS here. Uses both UDP and what? And TCP, depending on the instance that is being used. All right. Then let's look at DNS in full. How does it work? What does it mean? Let's use the diagram to illustrate the behavior of domain name system. So the basic foundation I want you to understand here is that what DNS does is what enables us to be able to use domain names. And domain names are things like google.com, iospine.com, www.cisco.com, www.facebook.com. Those are domain names that we are using. That's how we recognize websites and links, places that we need to visit using our web browser. Now, what I want us to understand in this explanation is that your computer understands IP address. It doesn't understand those names. Your computer works with numbers. So what happens is that when someone buys a domain, okay, when you purchase a domain, you are buying what? An IP address in disguise. You are buying an IP address in disguise. You are buying an IP address in disguise. So you are buying an IP address in disguise. Now, that IP address that you are buying will be linked with that name that you are paying for. Okay? So let's say you are buying ispine.com. That ispine.com, okay, is an IP address, which I will show you in a demonstration that we are going to do. All right. So now how the DNS works is that there is a DNS server on the internet, okay, or on the network. That DNS server has a table, okay, like this, that has both name and IP address. So let's say the IP address of this first server is 10.1.2.3. That's the IP address. This is IP version 4 address. We said that is what? 4 octets. Okay? So this is 8-bit, 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 8-bit in 4 places. 4 clusters of 8-bit. So the domain name, let's say the domain name is server, something like google.com. Let's just say server 1. Then we have another one, server 2. So your DNS server knows all the IP addresses and their domain names. So it has a map, kind of. Now, you are here in base 11. You want to visit google.com. Let's say google.com is server 1. So when you make a request in your browser, your browser will not just go to google.com. Your browser will first of all look for the IP address of google.com. So it will do what they call DNS lookup. To make a request to a DNS server, okay, which is called configured. When you are receiving the configuration setting, the DNS server IP address is already there. So that request happens without you knowing. Sometimes in your browser, you will see it showing in the lower left-hand side, of your browser screen, saying DNS lookup. So there will usually be a DNS lookup. So that DNS lookup will look for the IP address of that domain name. So it will make a request to DNS server, and then that DNS server, it will search for that domain name and return the IP address of the domain name. Okay, so it's sending you that server 1 is 10.1.3. Now, the encapsulation process in your client will now be complete because it now has the destination IP address to forward the packet to. Now forward the packet with server 1 IP address 10.1. That is how the request will know that it will come to server 1. If I wanted to go to server 2, lookup will return 10.1.6 so that the request will now go this way instead of this way. Okay, so this is the behavior of what? Of DNS. So DNS maps IPs to domain names and domain names to IPs. So this is really, really very, very important. If you try to type an IP address, give you domain name. If you use domain name to give you IP address. So the DNS server has, their translation for you. Okay. Then let's talk about HTTP, Hypertext Transfer Protocol. Hypertext Transfer Protocol. This is a protocol that enables the web. Okay. That is the port number 80, www. It allows your web document to be sent across the internet. This port number is 80. So a more secure version of HTTP is HTTPS, which you can get by purchasing an SSL certificate for your site. HTTPS ensures that information sent to or is retrieved from web server is encrypted. This port number is 443. So we can see it in this table here. Okay. You see HTTP, we have HTTP here. Okay, port number 80. Then we have SSL, port number 443. When this SSL is bought, on top of this, your HTTP, you have what? HTTPS. So, and you are usually advised that when you want to purchase something online, make a transaction online, you should make sure that the site is secure. The reason why it's secure is that this secure socket layer, this SSL, to scramble your information, encrypt it, to make it so that people who are trying to hack or take a look at, spy what you are sending across the internet or your network, okay, they will make it difficult for them to see. Okay, maybe where they are supposed to put S, put comma, semicolon, hyphen, space, 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 that kind of thing. So you just scramble the data so that they will not be able to get it. But the receiver will be able to assemble or decrypt whatever that has been sent. So that is HTTP for you. Now, we usually encounter certain status code. Okay, these are just few of them. in web development or when we are browsing the net. So for example, 200, okay, you may not be seeing this one, but I know we might have encountered 404 not found, 403 for BD, 500 internal server errors. So they have their meaning. So whenever it is 200, okay, that means everything is well. The response, you made a good request and you are getting your response, everything is fine. Okay, it may not be displayed to you on the browser, but that is what it is. To return, the server will return 200 okay to your client. And when the server returns 301, it means that the page is now at a new location. Okay, so it might automatically redirect. 302 is that the page is now at a new location temporarily. 401 is unauthorized when you need to provide login credentials to access a particular view on your web page. 403 forbidden is when the server will not permit your request because maybe you don't have appropriate permissions. And 404 not found is when the server cannot find what you asked for. Okay. Then 500 internal server error is when there's a server failure, when your request will not be able to go through. So those are basically some of those things that are there. So in our next video, we'll talk about some web technologies. Look at websites, web pages, web servers, and URLs. Thank you.